angles that are measured from the positive x-axis in a counterclockwise sense are positive, and those angles that are measured in the clockwise sense, they are taken to be negative. The angles are measured like that. Take note of that, because we have positive angles and then negative angles. And when it comes to ratios, you may find that a certain positive angle has a ratio resembling a certain other negative angle. And now the axes, the x-axis and the y-axis, they divide the plane into 4 quadrants, and the angles are measured from the positive. The angles are measured in the anti-clockwise sense from the x-axis. So that means that you have the first quadrant in the from 0 to 90, then the second quadrant 90, between 90 and 180, third quadrant between 108 and 270, and the fourth quadrant between 270 and 360. Those are the quadrants. Take note of those quadrants, because we shall be talking about quadrants a lot in this trigonometry. Now let us see, supposing we have a point P with the coordinates x1 and y1, we can write there, we can complete a certain right angle triangle like that. R can be got by Pythagoras theorem, and it is always positive. Y1, x1, take note of those values. You have now the sine of theta 1. Sine of theta 1 is opposite divided by hypotenuse, so that is going to get us y1 over r. The cos theta is adjacent, which is x1 divided by hypotenuse, that is r, and it is positive. All of them actually are positive in this quadrant. Tan theta is opposite over adjacent, y1 over x1, and you will be noting that that one is also the same as sin theta 1 divided by cos theta 1. So tan theta 1 is y1 over x1, which is also the same as sine of theta 1 divided by cosine of theta 1. And now for a point P, xy, which is distant r from the origin, we have these values here. Sin theta is equal to y over r, cos theta is x over r, tan theta is y over x, which is the same as sin theta over cos theta. And then we have other three ratios. We have cosec, which is the reciprocal of sine. We have sec, the reciprocal of cos, and then cot, which is the reciprocal of tan. Cosec theta is 1 over sin theta. Sec theta is equal to 1 over cos theta, and then cot theta is equal to 1 over tangent of theta. Let's move to the second quadrant. How do we handle things in the second quadrant? You have the same point P and the angle theta 2. You can take note of the angle theta 2 measured from the x-axis counterclockwise. That angle is theta 2. It is used, we can get the values of the ratios of that angle by using the same values, the same ratios we used in the first quadrant. So even in the second quadrant, sin theta 2 is y2 over r, cos theta 2 is x2 over r, and tan of theta 2 is y2 over x2. And now we have here that sin theta 2 is the only one which is positive. Why? Because sin theta 2 is y2 over r, and y2 is positive in the second quadrant. In this quadrant, y2, the y's of this side are positive, but the x's are negative. As you can see from 0 this side, negative. So x is negative, and because x is negative, x2 over r, which is always positive, r is always positive. So you have a negative x2 divided by r. For cos theta 2, we have a negative value. Then tangent of theta 2, you have y, which is positive, divided by x, which is negative, that is going to get us a negative value. That is what we have in the second quadrant. What about in the third quadrant? All angles are measured from the positive x direction, like so. The angle is theta 3, as you can see it. The ratios still hold, they are still holding, but how do we talk about the negative and the positive? Sin theta 3, the sign of that angle is negative because it is y over r, and the y in that quadrant is negative. R is positive, so negative over positive. The cosine is negative because even x is negative. And the tangent is positive because tangent is y over x, and y and x, both of them are negative. So negative over negative will get us a positive. That is for y. That is for tangent of theta. So the tangent of theta is positive in the third quadrant. What about when it comes to the fourth quadrant? The angle theta in the fourth quadrant, that angle is going to be between 270 and 360. Point x4, y4. The ratios are still there. Sine is that, and the cosine, they are all of them with the same ratios. They are like that. But how do we get the negative? Sine theta 4 is negative because y is negative. In the fourth quadrant, y is negative, and the sine theta is y over r. Cosine of theta is positive because x is positive there, and even r is positive, so cosine is positive. Tangent is negative because it is we are having a positive. Actually, it is a negative divided by a positive. So that value is going to be a negative. Tangent theta is negative in the fourth quadrant. And in summary, we have the quadrant circle like that. This one is showing us which ratios are positive in every quadrant. In the first quadrant, all ratios are positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. All angles with the same inclination to the horizontal have related ratios. This one is a general thing for any acute angle. You can get angles in the different quadrants that are related to that particular acute angle. I am going to demonstrate this fact using an angle of 30 degrees. Let us consider this Cartesian plane. You have an angle of theta equal to 30 degrees. Take note that that one is now an acute angle. It is the angle in the first quadrant, and in most cases that is the angle in the first quadrant. In most cases the angle you get by getting the aka sign, aka tan, or aka cos of a given value. You get an angle in the first quadrant. So when you get an angle in the first quadrant, what follows next? Like now we are saying that we have these angles 30 degrees. I'm trying to talk about positive angles versus negative angles. And this one is supposed to help us in attempting the questions set by examiners. The question is that bear strings. They tell you find the values of theta between negative 180 and positive 180. So if you get an angle, like in the third quadrant, you get an angle of 210 degrees. That angle is going to be outside the range. So in that case, you consider the negative 150 degrees as the value of the given angle. Now, for an angle of 30 degrees, for every positive angle, which is measured anti-clockwise from the positive x direction, there is a negative angle which is measured clockwise from the positive x direction, like so. Like for any angle of 30 degrees positive, measured from the positive x direction counterclockwise, there is a negative angle of negative 330 degrees measured clockwise from the positive x direction. Now that is what we have from the first quadrant. What about when you come to the second quadrant? In the second quadrant, the angle which is related to 30 degrees is 150. And for 150, there is a negative angle, negative 210. And it bears the same ratio as that one of 150. In other words, the sign of 150 is equivalent to the sign of negative 210. And what you need to note is that these angles are having an inclination to the horizontal of 30 degrees. The 30 you got in the first quadrant. Now, what about in the third quadrant? In the third quadrant, any angle related to 30 degrees is 210. Positive 210 if you measure it from the positive x direction in the anti-clockwise direction. But for that particular angle, there is a negative angle, which is negative 150. And what you should note is that those angles, they have an inclination of 30 degrees to the horizontal. 210, negative 150. In a case where they want you to write an angle between negative 180 and 180, you can see that now you have negative 150. In a case where you get 210 as the positive angle, you just have it as negative 150 degrees. In the fourth quadrant, the angle which is related to 30 degrees, which is inclined to the horizontal at 30 degrees, is 330. And the negative angle is negative 30 degrees. Inclination to the horizontal, it is 30 degrees. So 330 is beyond the range of negative 180 to 180. So in that case, you just write negative 30. What I'm saying, for every positive angle, which is measured counterclockwise from the positive x direction, there is an angle which is negative with a similar ratio, which is measured in the clockwise sense from the positive x direction.